Welcome to another session on word problems with regards to rational functions. We have another word problem here, and it says working together, Albert and Varouche can deliver flyers to all homes in their neighborhood in 42 minutes. So these are two fellows, Albert and Varouche. They work together, they help one another. Of course, one may be a slow worker, one could be a faster worker, but together it takes them 42 minutes to deliver all the flyers in their neighborhood. But when Varouche works alone, all by himself, he can finish the deliveries in 13 minutes less time than Albert can when Albert, works alone. Okay? So it says find the time that Albert takes to deliver the flyers when he works alone. All right? So that's what we want to find here. Obviously, when they work together, the time uh, is like a lower value, like 42 minutes. That's a good time because they help one another. They can finish up the job faster. But if they work all by themselves, even if they're fast workers, there's nobody to help them. So in that case, I think the number of minutes would be very high. So if Albert or even Baruch works all by himself, I think the final answer to the question should be an answer which is more than 42 minutes for sure. Okay. So here we have to pay attention to one thing. First of all, we are going to let t, our variable, to equal to number of minutes it takes Albert to finish the job. So t is the number of minutes that Albert finishes the job delivering the flyers all by himself, all alone. And then the question says that Varouche perhaps is a faster worker and it takes him 13 minutes less time compared to Albert. Maybe Varouche is like delivering the flyers faster or running faster or whatever. So the time for Varouche only, all by himself, working alone, is t minus 13 minutes. So let's pick some value for t, okay? Let's say t is like 80 minutes, okay? So if t is 80, then 80 minus 13, that's going to be how much? 67 minutes. So if it takes 80 minutes for Albert to finish the job all by himself, then Varouche can do the job in 67 minutes all by himself. I just gave an example of t equals 80. And 80 is actually 80 and 67 both are bigger than 42 minutes. So if they work hand in hand, they help one another, they're going to finish the job in 42 minutes. So if Albert took, let's say, 80 minutes to deliver all flyers, he would deliver 1 over 80 of the flyers per minute. 1 over 80 of the flyers per minute. So just, you got to think about this idea. If somebody finishes a task in 80 minutes, then what is the fraction of the job that he's actually doing in 1 minute, which is the unit of time, let's say? So it will be 1 over 80 of the job done per minute. And after 80 minutes, 80 times 1 over 80 would be just 1, and that would be the whole job. So here, we are using this idea that fraction of deliveries per minute when Albert working alone, if we add that fraction with the fraction of deliveries per minute when Varouche works alone, that would be equal to the fraction of deliveries per minute when both are working together. So when Albert is working all by himself, okay, it takes him t minutes to finish up the job. And that's the delivery of the flyers. In some other questions is painting a room or whatever task that is. So 10 minutes it takes Albert alone to finish the job. That means that 1 over t would be the fraction of the job that will be completed by Albert if he works all by himself. And the same fraction is 1 over t minus 13 because Varouche's time all by himself alone is t minus 13. So 1 over t minus 13 is the fraction of the job that can be done by Varouche all by himself. So he does one fraction and the other one does another fraction of the job per minute we're talking about. And the fraction of deliveries per minute when both working together is obvious that it's 1 over 42 because we know exactly it takes 42 minutes for these two working together, helping one another, finishing up the job. So if it takes 42 minutes for them to finish up the job, it means that in 1 minute they can finish 1 over 42 of the job, if they work together, of course. So by adding these two fractions, setting it equal to 1 over 42, we end up with another rational equation. And all we have to do now is to solve this rational equation by finding the lowest common denominator. And if you do that, it's going to be t times t minus 13. And simplifying the numerator, you get 2t minus 13 over t squared minus 13t, and that's 1 over 42. Now we do the cross multiplication. So that is going to be 84t minus 13 times 42. 13 times 42, we need a calculator. It's going to be 546, hopefully, and then equals t squared minus 13 times 1, obviously. So rearranging the terms, we get t squared, and then minus 89, so that's going to be 97. T plus 546 equals 0. Basically, we end up with a quadratic equation. Now, if you spend a little bit of time to see if you can find two numbers that add up to negative 97, but their product is 546, and you can, of course, use your scientific calculator, you'll see that the two numbers are 91 and 6. They add up to 97. I mean, negative 6 and negative 91 add up to negative 97. And the product is 546, from where we get t equals 91, because, we use the zero product property. We're going to say either t minus 91 is 0 or t minus 6 equals 0, from where you get t equals 91 minutes, or you get t equals 6 minutes. So we got two answers. But the thing is that Baruch can finish up the job all by himself 30 minutes faster compared to Albert. So if t is 6, and I plug in 6 here, 6 minus 13 would be negative. So because this answer is less than 13 minutes, so we're going to count this as an inadmissible solution. Okay? T cannot equal to 6. It has to be more than 13 for sure. Otherwise, the Baruch's time would be negative. People will laugh at us. So we're going to go t equals 91 minutes as our final admissible answer. So what was this t? It was Albert's time. So we're going to say Albert takes 91 minutes to deliver the flyers all alone by himself. This is the final closing statement, or the paraphrase that we write here. You know that there's a process for problem solving. There's 4 steps you have to follow. The first step is to write your let statement. That's when you are introducing your variable, okay? And usually that variable is what is the unknown in the question. The question says find it out for an Albert's time alone, so t has to be Albert's time alone. So that's step 1. Step 2 is to make a plan, and that is actually coming up with the idea of adding the fractions, setting it equal to the fraction of the deliveries per minute when both working together, and constructing actually the rational equation. That's the plan, constructing an equation end of the day. Sometimes in lower grades in high school, we construct a quadratic equation. In this case, we are constructing a rational equation. And step 2 is over. Step 3 is when you carry out the plan, and that means solving the rational equation or quadratic equation, whatever it is. That's the third step. And finally, the fourth step is to answer the question by writing a final closing statement or a paraphrase, which we did. Albert takes 91 minutes to deliver the flyers all alone by himself. And that's what the question was asking. It says, find the time that Albert takes to deliver the flyers when he works alone. Now, I'm curious about the other guy, Varouj over there. So t minus 13. So 91 minus 13, that's going to be 81.78, I guess, right? 78 minutes. So this means that Varouj takes 78 minutes. Okay, so this is going to be time for Varouj if he works alone. okay, by himself. And you see that this time is less than 91 minutes because Varouche is working faster compared to Albert. And both of these numbers, 78 and 91, they're larger than 42 for an obvious reason. Because when two people work together, they help one another, they finish up the task faster, so it takes less time for them to finish up the job, only 42 minutes. But if every individual wants to do the task by themselves, all alone, it would take 90 minutes, 91 minutes for Albert, and 78 minutes for Varouche. I hope you understood this word problem, and I strongly recommend for you to watch these video lectures multiple times, because I have restrictions to prepare these in a short period of time. So, but you have this option of pausing and then rewinding and then replaying. You can watch this like 2, 3, 4, 5, 10 times as you wish, and you can take notes and you can hesitate, and then go back and watch one part of the video at the beginning, and until you fully understand. But I have to make these in a very short period of time. Keep practicing as always. Thank you.